We now go for the solution for 3-28. The table below represents the decision table. So in this case, we have the decision alternative, which is small, medium, large, or very large. For a good market is 50, 80, 100, 300. For a fair market is 20, 30, 30, 25. For a poor market is minus 10, minus 20, minus 40, minus 160. The maximum across the row for small, the highest value among the 50, 20, minus 10 is 50. The highest value among the medium is 80, 30, minus 20. The highest is 80. The highest among 100, 30, negative 40 will be 100. The maximum among the 300, 25, negative 160 is 300. The first question asks for the maximax. The maximax is the highest of the highest. And the highest among the highest here is 300 with a decision alternative of a very large facility. Again, the highest of the highest here is the value of 300, and we go the very large facility for the A part. The B part asks what we call the maximum decision. The minimum among the 50, 20, 10 is negative 10. 80, 30, negative 20, negative 20. 100, 30, negative 40 is negative 40. 325 negative 160 is negative 60. These are my minimum values. And in order to work out the maximum among the minimum values, the highest among the minimum value is a negative 10. So therefore, the value for the maximum is to go with a negative 10 with a decision alternative at a small station. The highest among the minimum value, all these are minimum values, the highest among them is negative 10, and we go with a small facility. Then we go with the equal likely decision. Equally likely means averages. So it's 50 plus 20 minus 10 divided by 3 is 20. 80 plus 30 minus 20 divided by 3 is 30. 100 plus 30 negative 40 divided by 3 is 30. 300 plus 25 minus 160 divided by 3 is 55. Among all these values of 20, 30, 30 and 55, the highest average here is 55. So I go with a large, very large station, and the value is 55. Again, the average here, highest of the average is 55. So I go with the highest average value, which is what, 55, gives me a decision alternative of very large. Then I go now to the other part of the question, which asks to work out the criteria of realism. Now for the criteria of realism, it's alpha by the highest multiplied by 1 minus alpha by the lowest. My highest values are 50, so it's 50 by 0.8 plus minus 10 by 0.2. Minus the highest value of 80 by 0.8 minus 20 by 0.2 is 60. 100 multiplied by 0.8 plus negative 40 multiplied by 0.2 is 72. 300 multiplied by 0.8 minus 160 by 0.2 is 28. Again, is the alpha by the highest. Alpha is 0.8, so it's 50 multiplied by 0.8 plus minus 10 multiplied by 0.2. So it's 80 multiplied by 0.8 minus 120 multiplied by 0.2 minus 100 multiplied by 0.8 plus minus 40 multiplied by 0.2. 300 multiplied by 0.8, I'm going to then minus 160 multiplied by 0.2. I get the values of 32, 60, 72, and 28. Among all these values here, the highest value is 28. So therefore, my criteria realism value is 28, and my decision is to go with the very large facility. Then we go now to what I call the opportunity loss table. Just as before, the highest among 50, 80, 100, 300 is 300. So it's 300 minus 300 is 0. 300 minus 100 is 200. 300 minus 80 is 220. 300 minus 50 is 250. The highest among the 20, 30, 30 and 25 is 30. So it is 30 minus 25, 30 minus 30, 30 minus 30, and 30 minus 20. 30 minus 20 is 10, 30 minus 30 is 0, 30 minus 0 is 10, and 30 minus 25 is 5. The highest among all these values here is minus 10. So it's minus 10 minus minus 10 is 0, minus 10 minus minus 20 is 10, minus 10 minus minus 40 is 30, minus 10 minus 160 is 150. And then I have the opportunity loss table here. The maximum in the columns now going across 250, 10 or 0, I take the 250, 220, 0 or 10, I take the 220. The highest among the 200, 0, 30, I take the 200. The highest among the 0, 5, 150, I take the 150. And here we have the opportunity loss table in terms of thousands. Thank you.